Hello students, Dr. Shruggy here, and we're ready to move on to the next project. This is project 2 in our class, and you're going to be doing some descriptive statistics of a big database of temperature records that I downloaded for you for Nebraska. We're going to learn about how to work with them in Octave and how to do basic descriptive statistics, things like averages and correlation, and how to make graphs like histograms and so on. All of this will be very useful as then we move into the future projects where we're going to be building statistical models, where we're making predictions of power consumption or whatever. Now, in order to do this though, we have a challenge that we didn't have in the first project. We have to first get the data that already exists into Octave so that we can do something. We never had to worry about that in the first project. In the first project, we were doing a more explicit dynamic calculation. We were actually using math to compute sun angles and so on. Now we have to take data and we have to actually bring them in to Octave, and the command that does that is a command called load. Octave's load command takes a data file that has already been set up in a format that Octave expects and puts those values into the appropriate arrays or variables or whatever. We're going to be working with this load command in a very simple way in this class, but there are more complicated ways that you can use Octave's load command and its corresponding save command to save more than one variable and so on. That's just not where we're going with it at the present time. So what you do is you're going to be working with files that I have already set up for you. Now on Chesapeake, there's a directory called /data/ERG301/Nebraska/8years.mat. I'm going to show you what that file looks like. Over here in this window, I am in the directory data/ERG301/Nebraska, and in that directory right at the present time there's a whole bunch of stuff, but one of the files that's in there is a file called 8years.mat. And this is a file that, well, let's actually take a look at it. I'm going to open it up in the editor called VI because I'm more familiar with VI than I am with Nano, but Nano would have been fine too. And I'm going to load the version that's called 8years.mat. And this is a huge file. At the present time it has over 480,000 lines in it. But the first 4 lines are what Octave is looking for to understand what this file is. The first line is telling us the name of the variable. I rather uncreatively called this data that we are loading in, I called it data. Okay, I could have called it whatever, but I called it data. The second line is going to tell us the type of variable that it is that we're loading in. As it happens, this is a matrix. It's a two-dimensional array of data. You've worked with matrices in math classes and so on, so you know what a matrix is. And then the third line tells us the number of rows in the data. In this case, at the present time, there are 485,000 lines in this file. This is an 8-year record of temperature data from Nebraska. I'm trying to actually download a few more years of data for your actual project, so you may actually have 10 years or even 12 or 15 or something when you actually get time to do the project. But as I'm recording this, I only have 8 years downloaded. The website that you get these data from are very, very slow. Is very, very slow. And finally, the last row of those 4 rows that describes the data is just a little file, a little line that tells us that there are 6 columns in this data set, in this matrix. And then after that, there's literally hundreds, in this particular case anyway, there's literally hundreds of thousands of lines of data. Numbers, 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 and it just goes and goes and goes for hundreds of thousands of lines. What are all those lines? What's going on in this file? This file, and again I'll use the same, this happens to be the 8 years version, but we will be using a similar version if we do 10 years or 15 or whatever for the project. The first column here is a station number. I'll show you in a little bit where these station numbers come from and so on, but like for example, this first observation here is for station number 8. Okay. The second column is just the year. This happens to be the observation from 2007. The third column is the month, so it's an observation that was taken in January. The fourth column is the day, so this is January 1st. See how it's 2007-1-1, so it's the 1st of January. The fifth column is the first of the ones that actually has numbers that we care about. This fifth column is the high temperature for the day in degrees Celsius. So on that particular day at station number 8, the high temperature was 0.2 degrees Celsius. And the sixth column is the low temperature for that day in degrees Celsius. So the low temperature that day was negative 11.3. Alright, so we have 6 columns of data by hundreds of thousands of rows, because there are lots and lots of these cooperative weather stations in Nebraska. And so we have records for hundreds of stations over the course of several years. It adds up to a whole lot of data. So this file, which I currently have way up in the /data directory, /data/ERG301 /Nebraska/8 years, is a two-dimensional array. It has rows and columns like a spreadsheet. And at the present time, it contains 8 years of high and low temperature records across Nebraska. And I don't know, there's about 210 stations or something like that. These are not official National Weather Service stations. They are cooperative observers mostly. Individuals who get a little bit of training, and then they get a weather station that they take records from and send them in to the National Climate Data Center. Okay, so how do we actually work with how do we actually get this data loaded into Octave so that we can do something with it? Well, in order to do that, we're going to need to be working with an Octave program. We're going to be writing an Octave program just like we did before, so I'll move over to this other window here. And I've been making a program, I'll use Nano here for a second, example.mat. Okay, this is my program. And at the present time, I just have one line in that program, load, and the name of the file that's already formatted in the way Octave is expecting. So in this case, I am loading /data/ERG301 /Nebraska/8 years.mat. Again, for your project, it might be 10 years, it might be 15 years. It depends on how much data I can get downloaded from the rather clunky website. So at the present time, that's all I have in this little Octave program. And then I'm going to go ahead and exit that, and I'm going to go ahead and run it. Now, it's been a while, it's been a couple weeks since you've done any Octave stuff. So let me just remind you that you launch the Octave interpreter, and then you run the name of the program. Don't run the data. I know that they both have .mat file extensions. That can be a little bit confusing. But you want to run the name of your program, which in this case I called example.mat. And when you run it, you can see it takes a few seconds because, I mean, Chesapeake is actually sitting there loading 400 and some thousand rows of data. And we certainly will get to even bigger data sets over the course of the semester. But now we have actually run the program, and in memory right now there is an array called data with 6 columns and 480 some thousand rows, and we can actually use the who's command to see it. Look, we actually have an array called data. It has 485,000 rows by 6 columns. It currently takes up, what is that? Is that 23 megabytes? Yeah, 23 megabytes of data. So that's not so big in memory. Alright, and we can actually take a look at it. Now, if we actually take a look and say, like, disp data, we're not going to be happy with what happens here, right? I mean, if I start displaying this data, well, I mean, I can see here, it's 1, 2, 3, 4, 5, 6 columns, and it's going to go, I mean, we could keep scrolling forward and forward and forward and forward, but I mean, that's going to be 480,000 lines. We aren't thrilled with it. But I see the data there. I'm going to type Q to get out of this here. Okay, and I'll type who's again, just so we can see that it's still there. Okay, displaying the data is not so easy like that. On the other hand, we have simpler ways that we could do this. For example, I could just take a look at the first row of data by saying display data row 1 column colon. Now, okay, when I did that, I can see I did get it. Look, there's 1, 2, 3, 4, 5, 6 values, as there should be. The first one was 8 because it is station 8. The second one is 2.007 times 10 to the third because that's 2007, the year. Then we got the month 1 and the date 1 and the low temperature and the high temperature. Yes, they're right. Okay, I'm sorry, the high temperature and then the low temperature. So they're right, but wait a minute. What was this business of this colon? See that little colon I have right there? When you're using an array, like a two-dimensional array of data where there's rows and columns, a colon means like across all, or all available, or something like that. Data 1 comma colon means show me all of the data that is in row 1, any column. Okay? So like we could do the same sort of thing. We could look at the 1000th observation by saying data 1000 colon. Oops, I have an extra character there. So look what it's doing here. It's going to show me the 1000th row, all columns. Okay, so as it happens, the 1000th row is apparently from station 10. It's still in 2007, The month is 10, so it's from October. The date is 2, so it's the 2nd of October 2007. And there's its high and there's its low temperature. Okay. Or we could do things like see the 6th column of the data. We could do that by saying like display all rows the 6th column. See how again that colon means just show them all? Alright, we're going to be using that colon a lot in this module. Alright, we're seeing column 6. Now this is going to take a long time to scroll through because column 6 is the maximum temperatures? No, the minimum? Whichever one it was. Minimum, I think. But there's 480,000 of them. Okay, so I mean, I don't want to scroll through all these guys, but they're all there. Okay, so we can look at the 6th column, or for that matter, we could take a look and see the 2nd column of data. So all rows column 2. Okay, well these are actually just the years. It's not that exciting. We're looking, like for example, all these observations are from 2007, but if I scroll down far enough, yep, they start hitting 2008. Okay, so that's not so exciting. Or I could take a look, for example, at column 1. I could say display all rows column 1. Alright, and these are those station identifier numbers. Like, for example, first we're on station 8, and if I scroll down far enough, it's a little hard to tell I'm scrolling as I press this F. Now we're on station 10, and so on. So I got these station identifier numbers. Now, what are these things? They're not something official. They're something I just made up. Let me show you here. Inside that data ERG 301 Nebraska directory, let me go back over here to this window where I have that. So here I am, let me clear this out. Here I am in the data energy 301 Nebraska directory, and in here I have a file called reference table. And if we just go ahead and take a look at this file reference table, there we go. This row, sorry, this is just a table that I built as I was reading their database. That station 1, the official station identifier of this place is GHCND:US10HITC017. See how calling that station 1 was a whole lot easier than dealing with that stupid number? Okay, so I just went through and gave it, I mean, the National Climate Data Center has to deal with tens of thousands of these stations. They have these big complicated codes. We'll call it station 1. That's fine. And for what it's worth, here's where it happens to be 6.1 miles east-southeast of Palisade, Nebraska. We could go through here and find all kinds of one. Here's this one right here, let's just say. Oh, let's look at station 8. That's the one we were just on. Okay, so station 8, which is, who cares, this weird station number, happens to be 8 miles east-northeast of Lincoln, Nebraska. It's probably some farmer who happens to have training to be a cooperative weather observer. And you can go through, and there are about 1,200 cooperative weather stations in Nebraska. And so, you know, we could scroll through here. Here's somebody, you know, station 121, here's its horrible name. It's actually 8 miles east-southeast of Gordon, Nebraska. Okay? And you can scroll through, and there's literally like right around 1,200 of these here. But as it happens, not all that many of these weather stations, these 1,200 weather stations in Nebraska, happen to have max-min thermometers that can actually record the maximum and minimum temperature of each day. Some of them only have like rain gauges and so on. And so to simplify matters just a little bit, I went through and actually figured out which ones are the ones that have the max-min thermometers. And that is in a file called reporting stations, I think, yes, reporting.stations. And this is just a list of 203 station numbers that this is where there are max-min thermometers. Okay, so like if you look over here, remember our first station that we kept hitting was 8. 8 happens to be the first station that does have, so stations 1 through 7 only have like rain gauges. Some of them are only like ag research stations that only have ways to measure soil moisture, things like that. So 1 through 7 didn't have a thermometer, but 8 does. You're going to find this useful later in the project to have a list of what stations do and don't have the temperature data available. Okay, that's everything you need to learn about how to do loading of data. Now we're going to move on in the next lecture to learning about how we are going to be doing database operations on here. I mean, this is a very large set of data. Well, it's pretty large. How are we going to extract from here? I just want the temperature data from Alliance, Nebraska. I just want the temperature data for 2007. I just want the stations that are, you know, whatever, have temperatures greater than 10 degrees Celsius. How are we going to extract things like that? How are we going to pull things out of this big data array. We'll do that in the next lecture. In the meantime, play around with this a little bit and let me know if you have any questions. This has been Dr. John Schrage.